So as was mentioned, the topic for today is really around AI and how your enterprise can take advantage of that and leverage that. It's a fairly broad space. So over the next 35 plus minutes, and we'll add some Q&A at the end, but please feel free to ask questions as we go. It's going to be a bit of a broad journey around what is AI, and a lot of people have different ideas, how you can use it, how you can leverage it, and really what are the elements that an enterprise needs to look at to have a successful AI strategy. And I mean that AI strategy from very much an IT perspective, because that's often the biggest challenges that people face. And we all know that data is the new oil, and the like, but it's about how you refine that oil, how you extract the value from that data and what you do. And that's really where AI is. And when we talk about AI, many customers of ours say, oh, we already have a digital business. But the key thing is here, we're going beyond a digital business and we're going into an algorithmic business. And what this means is the machinery of your business, as well as people and process, those processes become automated and internally decision-making. So you've got things the like nature of bots and things like that, which can augment what people do and scale faster and to larger data sets and more information. And also perhaps work in different locations, right? And also they never sleep. This is not really a way to replace people, it's a way to assist people in what we do. And there are always some critical decisions that are never taken by machines, needless to say. Now, probably one of the most important questions that we often will get, or sometimes people don't ask, is why is NVIDIA talking about AI? Doesn't NVIDIA make graphics cards? And the answer is actually fairly simple. Yes, we do make graphics processing units, but the point here is really around the word processing. So when we talk about AI, it is an exceptionally complex computational problem, and I'll show you why in a minute. And GPUs, when harnessed correctly, unlike CPUs, can assist in massively parallel computing. They've been used in high performance compute for many, many years now, since about 2008. But in AI, that really started around the 2012 mark. So we're talking about using cards with up to 10,000+ cores on them. And once you start putting a few of those into a single box, as well as having multiple servers scaling out, you can see why GPUs make a really big difference, just purely in the computational sense. But I'm going to talk more about the software side of things today, because that's where the workloads run and where most of IT spends their time. So coming back to IT and coming back to AI, we do know that AI is going to be pervasive in almost every aspect of enterprises going forward, whether it be talent acquisition and talent retention, whether or not it's about marketing and targeted ads and things like that are certainly relevant, but understanding our customers more. Cybersecurity, again, machines operate at the speed of machines, humans don't. We can't analyze packets, but systems can do that, and they can do that cohesively across a broad range of systems. Manufacturing and production, we can do inspection for either anything as small as a motherboard or a hard drive platter to something as large as an entire site, just to make sure that everything is in good operational fashions. And of course, customer service. We've all encountered chatbots, for good or for bad, and making those a great experience for your customers is terrific. But sometimes you don't even want those to be customer facing. Sometimes you want them actually to be internal facing. So you have staff who come into a call center, they may not be very skilled. And of course, it could take 18 months to have them skilled, unless you give them the chatbot and they can hear what the customer's saying, do some research and actually come back and make the customer service representative seem like a well-trained, seasoned expert rapidly. That's a great way to show value to your customers with internal facing systems. And even digital prototyping, process automation, and generative design is a thing there as well. So very pervasive throughout many enterprises. But the thing we hear very often, almost half of AI projects never make it to production. Now, for those of you who've done any statistics analysis, you'll know that that statistic is a really interesting one, because the important thing is why. Does it mean that AI doesn't work? And the answer is no. We have AI on our smartphones, whether you're using Siri or Hey Google or whatever it may be, these things work. We know that AI can work. So why are enterprises having problems with this? And the answer is not necessarily where you think it is. The AI team and the data scientists can make it work, but can IT put it into production? Or maybe IT can put it into production, but is it working well for your business? And I'd like to come back to that algorithmic business thing again, where we talk about the machinery of business. If the machinery of AI is not working well, hey, I don't want to take that risk. This is not good. So almost half of AI projects never make it to production or get productionized. That's a very different story from AI never works half the time. Very different story. So how do we make it work? And how do we make it work for the data scientists? How do we make it work for the IT people? And is everybody else involved here we need to think about as well? And the answer is yes. We need to satisfy demands for a couple of different key groups in the organization. We've got to make sure that the IT people have a system that they can use and they're comfortable with and they're happy with it, right? Standard enterprise systems, not bespoke, not unique, but standard. But we can't make that the enemy of the AI practitioners. It's got to work for them too. They can't have something that, I know it works for IT, but it doesn't work for us. So it's got to work for both of them. And of course, the people who own the applications and own the business part here, the line of business people, you know, the managers there, it's got to work fast, it's got to be scalable, it's got to be scale up, maybe scale down, flexible, right? So we've got to make sure that all these people get what they want. And that's what enterprise AI is. Not just do you have AI, but enterprise AI. It's a very different story. So at the end of the day here, what we're trying to do as IT people is we're trying to reduce risk. We're trying to make sure that we have good performance and that over time, we scale as necessary. And we scale preferably rapidly and easily. So not the system that works well when it's this big, but doesn't work well when it's that big, but something that works well no matter what size we have. So in a data center sense, we're not talking about having individual silos and bits and pieces everywhere because IT doesn't like managing lots of different silos. And that's a really good thing. What we want is cohesive, unified, accelerated data center. So when we think about IT infrastructure, probably the most common platform that we talk about nowadays in enterprise is VMware, vSphere. Everybody's got it, there are skills everywhere, but it hasn't really catered very well to AI to date. It's been, hey, you can do virtual machines and not much more. Well, this has now changed. So this is where NVIDIA has got together with VMware, and we've made sure that we have the best of all possible worlds. So when we analyze those layers again and what people need, what we've got is we've got the AI tools and frameworks, which is for the data scientists, and that's where the NVIDIA software comes in. It's called NVIDIA AI Enterprise. And it's exactly what it says. It's AI from us for the enterprise. As for the management orchestration layer, nice and simple. It's VMware. So the VMware tools, when you say the word VMware, IT people go, oh, no, it's okay, it's good, that's what I want to hear. And as for accelerated systems, this is the performance piece, I'll come to that, but standards on servers, very, very important. So if we analyze this stack in terms of a business, what are the bits we have here? Well, down the bottom, we have our servers. And when we say NVIDIA certified servers, by the way, we're not just talking about something that's compatible, we're actually talking about something that scales well. So not compatible, but certified to run the workloads we need. I'll come back to that one. As for vSphere or Tanzu. Tanzu is the Kubernetes and AI operating component there. So it's vSphere. It's got vCenter, it's clustered, it's got vSAN, it's got all the things that the IT administrators know, and a few more, which is great. As for the data scientists and data engineers and the like, well, they have all the tools from us, and they're perfectly cloud native. So if you're a vSphere fan, this is using VCF. As for the AI people, they don't need to know about that. That's not relevant for what they're trying to do. But I'm just going to dig into those AI people just for a second here and just sort of share a bit about what they do and how they go about it. So for those of you with any form of data science background, and I'm going to expand on this in just a second. So we talk about the three sort of roles that data scientists do, and it's actually a bit more than three, but the simple bits are they've got to get their data prepared, they've got to get it ready. They've got to develop AI, train AI, make it ready, make it aware, make it to understand things, and then it has to be deployed. So there's a couple of tools we have for that, and they're sort of highlighted here. So for those of you who know a little bit about AI, you may have heard the terms TensorFlow or PyTorch. They're open source frameworks. We've got them here. We've got them GPU accelerated here. So again, optimized, the fastest they can be. As for the data preparation, how we get our data ready, so we turn a data swamp into a data lake, ready for extraction. That's NVIDIA Rapids. It's an open source framework that, again, is optimized for GPUs. And as for deploying it, it's something we call inference. There's a few other infrastructure layer components here as well, but they're only there to make sure things scale and work really, really well. The data scientists don't really have to worry too much about those. Now, what I'm going to do is just go a little bit into how AI works. Because a lot of people are uncomfortable with AI, and it's a bit like, I don't understand it. It's a bit unusual. What does it work? So let me give you the quick version here of how AI works. AI works through something called neural networks. Now, neural networks are basically modeled on the human brain. So for those of you with children or who are around kids, you see how they learn. And if you want to teach a child to understand what a cat is, it's pretty simple. You give them lots of pictures of cats and you show them and you say, cat, 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 cat. And eventually the child learns, well, catness, for want of a better word. They learn to identify a cat through experience. They've been trained to see a cat. And the neural networks we have in computers, even though they're files and computer systems, work the same way. They have these elements that form with weights and measures to understand there's usually 4 legs that you can see, but not always. Sometimes they're sitting down, or there's usually a tail. But again, sometimes it might be wrapped around, or they've usually got fur on them, except for those weird Sphinx cats. And they've usually got 2 ears. So they learn all of the elements that collectively make up a cat. That is a very, very, very complex framework. That is really mathematically hard. So you might have a couple 100 million pictures, and you've got to put them back and forward through these networks, right? It's incredibly complex, right? In the brain, we've got dedicated areas for some of this stuff. So for vision, we've got the visual cortex at the back, we've got emotions at the front here, we've got the language speech centers, the Broca's area on the right. So here, we do the same thing, we narrow down. But once you've done the hard, complex part of training on the big tin in the data center, you can take that training, kind of like taking an XML file, and deploy it somewhere else. And that deployment might be somewhere as simple as putting it onto your mobile phone, or maybe on a server somewhere at the edge. And then we're not doing training anymore. Now we do something called inference. And this is the equivalent of taking your child by the hand, taking them out into the world, and pointing to an animal and saying, cat or not cat? Now, if it's cat, if we train them well, they'll go cat. If it's a dog, they should go not cat. And computers do the same thing, or they do it in percentages like 99.9% cat or 0.001% cat. So it's trained. So now we can infer from our training. Now, the important thing about this is the inference bit is usually a lot mathematically less complex. Still fairly complex for CPUs, but even our small cards, the ones the size of a mobile phone, have got like 2,500 cores. So you can imagine the complexity they can handle pretty well. But the point here is, though, there's no more learning. So big systems in the data center for training, if you want to develop your AI, small systems at the edge for deploying. Not everybody needs to do both of these. If you want to deploy a system in a hospital or in a public safety environment or car parking or whatever it may be, you may not want to do the training part. What you might want to do, buy the software off the shelf and then deploy it. So if you're talking about parking, it might be 30 cameras. You might need 1 card and a tiny little server to do that, right? So that's okay. We don't need to have data scientists. We don't need to do the training. We're buying and deploying. Other people, those companies who actually develop the software, they need heaps and heaps of training, but not much on the inference side. Once they know the scale of what they do, that's pretty easy to do. Got a reference model. Some companies do both because there's no software in market for them. They have to develop it and then they deploy it pretty simply. So not too scary. But when you understand this, you see the life cycle of AI. And the life cycle of AI here is really focused around this data center for building and the edge for deploying, for the edge analytics. Right? And of course, this can operate in the cloud as well. And we need both hardware and software frameworks to make this work. Now, coming back to that software piece, that what we want to have in our business, what we want in our enterprise, what tools we need for our AI journey, they look like this. The first part is preparing your data. This is the data swamp to data lake. So here we do data preparation using something called Rapids. It's an open source framework, but we've accelerated it with GPU code, which means faster, you guessed it. Once we've got the data lake ready, it's been prepared by the data engineers, the data scientists use tools, as I said before, PyTorch and TensorFlow to be able to do what they do. Now, that's all really good. And there are other ones available as well. But what we've got is the capacity here for large-scale training with pre-packaged GPU accelerated frameworks. And then, once we think it's trained, ready to put out in the real world for inferencing. We've got some software that accelerates the inferencing. It's called a Tensor Runtime, so it compiles things, makes it faster. And we've got an engine called Triton, which allows you to scale out across hundreds of servers and do some pretty good magic there. So depending on what you want to do, you've got capabilities there for whichever part of your AI journey you're ready for. And some people, they might spend 6 months with the data preparation. That's okay. The tools are there no matter what you want to do. So when we talk about the orchestration and management, some people want to do different things. You may hear about containers or virtual machines or OpenShift or lots of different things. Are we going to constrain you? And the answer is, no, we're not. There's actually a lot of flexibility here on the vSphere architecture, no matter which way you want to do this, whether you want to run native containers or virtual machines or whatever, or flip back and forth between them. All these things are available using the software. So no stresses there at all. Flexibility is key because you're on an AI journey. Now, touching on that AI journey, and I'll just come back to what is AI again. People often ask the questions, okay, so you've explained the training and inference bit, but what can it actually do? What can it do for my business? And I'm saying this because people often don't know, and they ask us to share with them the journeys that many of our customers have been on. And I'll show you a couple of specific examples, but I'll start off a bit more generically. So I'm simplifying it slightly here, there's about 6 sort of things that AI can do. The first of all, detect if something is present or not, right? So is a cat there, yes or no? Now, examples here, we've got healthcare, retail, and finance. So one of the classic ones is, detection of cancer, for example, or, ads for finding if people are there and that sort of stuff. Obviously, cybersecurity, looking for threats. What type of thing is it? So cat, dog. In retail, what do we have in our basket? There's a customer of ours here in Melbourne, which is where I'm from, where you can put something on a scale to weigh it, and it will tell you if that's an onion or which type of apple it is, whatever it may be. So that's really quite fascinating because that can be used in lots of different areas. Segmentation, to what extent is it present? Right? So, for example, if you have floods, you can actually analyze where's the water, what's it covering, invasive species, fire, how much of the forest was damaged, all those sorts of things. That's actually really interesting in the medical space too. So if somebody has a blockage on their heart, or for example, sadly over the last couple of years with COVID, they're now training AI systems in quite an advanced way to detect if there's been any lung damage, for example, and things of that ilk. Predictions. Okay, we've all done that in shopping and that sort of stuff. So, where does the shopper want to go next? What do they want to do? That's both in a physical and online sense. In finance, that's really impressive with fraud, okay? So, and then we can tack onto the back of that a recommendation engine. So what should we do next? Again, very common in the medical space. Given the patient's history, given their current symptoms, we actually recommend this sort of treatment. Again, that decision is an adjunct to a human being making a decision. There's a classic one in finance, which I thought was really interesting, which was a company used this for approving and not approving insurance claims. Now, AI can't necessarily explain why it does what it does. When you say to a child, cat or not cat, and they go, cat, you go, why? They go, based on my experience, it's a cat. But why? I can't verbalize it. I know what I know. AI is the same. It's what they call the black box phenomenon. And there is a lot of work being done on explainable AI. But this company with their insurance claims, the system could approve an insurance claim. It was not allowed to reject an insurance claim under any circumstances. So if you're the insurance company and you might have, well, we've had some rather bad floods and the like here in Australia and fires over the past year or so, you need to be able to process a lot of claims very, very fast. So what do? You run all the claims through the AI. The ones that can approve, which are easy, so high volume, and for the business, low value, we just want them approved, send them through. The ones that are complex, route them to a human being. That's what we want to achieve. So the computer never says no, only a human being can say no. And that's the workflow we want. That's exactly how we want to do it. The last one here is really interesting, natural language processing. Natural language processing is not translation. Natural language processing is also not text-to-speech and things of that nature, or speech recognition. And all those things, by the way, can be done using AI. But natural language processing is extracting value from words. So if you can imagine looking at a health record, there might be 3 or 4 or 40 years worth of notes. Let's try and extract information out of that that's relevant. Because a doctor might do something today, and we would like to be able to link that to what's happened on previous visits, especially with across multiple doctors. Relevant for contracts, in the legal sense, as medical, in the financial sense, all these things are really interesting. And what we can do is take that language, take that information, that knowledge, not just the words, and then act on that accordingly. Okay? And that's when it comes back into recommendations and so on and so forth. So really lots of different things that can be done here. The breadth is fascinating. I'm going to give you a couple of use cases here, but I would like to say we actually have a customer success story that we go through. There's a PowerPoint deck, of course, that we have, and there's about 256 odd different success stories in there across a variety of industries. So I'm only going to touch very, very lightly, but this is more important to understand. If you think about the data you have in your business, how could we apply AI to some of those data sets, and what could it do? So in the retail space, we could be picking up people who are scanning the wrong items, so they pick the wrong tomatoes or scan the wrong type of banana. It could be making that quicker for them. So as they scan through with vegetables and goods of that nature, rather than packaged stuff, they put it in front of the camera and it automatically scans it for them and says, yep, no problems, 3 heads of broccoli, 3 cucumbers, 6 tomatoes, and they're just packing it into a bag, and it automatically gives them a ticket and says, here, scan this. Or links it automatically to their loyalty card, and then they just tap their loyalty card at the ticketing system, and it gets billed to their account. That would be nice. But here we can do things as well. For example, we can track where people go in stores. Now, if I'm in a handbag store, you're not really interested in the men or the children. What you are interested in is the demographic that's relevant, which is women. Where do they walk? What do they see? We're also interested, for example, in retail environments. If somebody walks in, if you want to pick my demographic and then target me with advertising, and it can be quite subtle. It can be on billboards and stuff. Or in a retail store, you might be worried about spills, right? Or queue length. The queues are getting too long, send people to the front, and things of that nature. Also in the back office, there's lots of different ways you can play with this. It's really, really interesting. If we step outside a single building and we go to what we call smart cities.
Next, I want to talk about NODA.
Oops, my apologies. That's got some audio up there. If we go to smart cities, we can actually talk about pedestrians and drivers and things of that nature, right? So tracking cities, making sure that things are smart, safe, and optimized. Traffic lights are a problem. If we talk about the scourge of cyber attacks, how do we pick those up in real time? And how do we pick those up in real time at scale across, well, maybe not just your enterprise, but multiple enterprises or multiple systems and data centers and things of that ilk? How do we do this at scale? Well, AI can help you with that. This is where AI works fast and at scale. It augments what humans can do and says, go over there and look at those systems, or this east-west traffic is not appropriate. So that's important. And of course, if we take the last couple of years, unfortunately, the terrors of COVID, businesses are planning for that in an interesting way. How many people are in what space, for how long? Are they wearing masks? Are they social distancing? Is there a linger time? How many people are left? How many people in our store? Are they staff? Are they VIPs? All sorts of things can be done using basic cameras. And you may have seen things like this at airports, which are being monitored by people. But we can go a bit of a step further here, and we can do additional sensor fusion. So RFID or Bluetooth detection on your phones and things like that. So making things really, really smart to make sure that, well, we're all safe at the end of the day. And in the medical space too, these things are really interesting. In hospitals now, the first thing we do when people get in there is we take off all their jewelry, including their smartwatches. And then we wake them up every 2 hours to check their observations. And nurses hate waking us up, but they have to wake us up to make sure we're okay. Well, now, how about we put on a smartwatch, link it to the system, just sleep. Sleep, we've got tracking of your blood pressure, we've got tracking of your glucose, we've got tracking of your oxygen levels, tracking of your heart rate, all sorts of stuff. That sort of stuff is really, really powerful. So lots of different use cases that we can do in a business. And the goal is to make us more efficient in what we do about our business. So let me come back to the infrastructure just here for a minute, because sometimes when people hear vSphere, they get a little bit concerned about, hey, virtual machines and speed and that sort of stuff. So I said before, performance is really important. The benefits of virtual machines with the benefits of bare metal performance. This is some tests we've done with some of our supercompute cards. It's called the A100. And as you can see, everything basically runs at bare metal performance. I think there's like 0.2 of a difference there on one of these. But the scale is really, really important. And there's some specifications here as to how we've run this test. And of course, if we go over to a step further across a variety of different sizings of, one machine, multiple machines and the like, you can see how things can scale out pretty impressively. The other one, again, coming back to my point of earlier, we're talking about, GPU versus CPU, and if I'm going to invest in a platform, what I want to do. And I really want to highlight this here that, CPUs actually can run AI, but the scale of which they operate is entirely different than the scale of GPUs. And people often ask us, hey, if we buy a server with your GPUs, is it going to be more expensive? And I can assure you that the answer is yes. If you put a GPU into a server, it gets more expensive, but it will perform at a much higher rate. So usually you end up saving large sums of money. And in fact, for customers that scale this out over dozens of systems, it's usually on the average about 1 to 10, 1 to 11 in terms of one server with GPUs is equivalent to 10 or 11 without. So if you've got, I don't know, a couple hundred machines, think about the rack space you're saving. Believe it or not, you actually save power. You save power on top of rack switching, all sorts of things here. And more importantly, your time to value goes up. A lot of these things here, and I'll come back to the retail one, it's important that you don't get too much latency between when, somebody typing things online and getting a response back, or however that may work. These things are really, really important for latency. And sometimes we're talking about 0.7 millisecond latency in how things work. GPUs provide that to a much greater scale than do CPUs. Now, we do actually have a rather large number of systems that we can have here. This particular one happens to be a Dell R750XA, I believe it is, but it's across a variety of different providers. And I mentioned before that we have the NVIDIA certified systems. So, as I said before, the important thing here is not that we're actually saying, hey, yeah, put a compatible GPU into a compatible server. But when you want to design something for scale, you say, hey, I've got a retail store, I have 150 cameras and I'm running this particular piece of software. So I'll pick on, for example, something called Everseen. It's one particular software, but there's dozens of them. Well, we can actually get a scaled server for you. We can actually tell you exactly what server you need if you're running that software with that many cameras at whatever frames per second resolution. We can answer that for you very, very accurately and make sure that your system is beyond compatible. But the networking, the storage, CPU, the RAM, and the GPUs were all scaled perfectly. So what you have now is a system that is certified to run, not just compatible parts. You wouldn't build your own machinery to put into your business. So don't bespoke your own servers. And I'd like to finish up here before we go into Q&A on a couple of things that are very relevant for some of our customers. And there's a question that's popped up in the window here from Richard. And thank you, Richard, for your question. And encourage other people to ask questions too. Many of the users cited in their struggle with how to scale AI across their business and this platform. So this is actually an enterprise that's actually done this. So the University of Pisa in Northern Italy, they actually had I'm going to call it a traditional AI system. So unique platforms with GPUs are built on open source Ubuntu with handcrafted open source frameworks. And it worked. It absolutely worked. But it was a unique, custom, fragile, bespoke system. And changes were problematic. So when we want to scale this specifically, pardon me, Richard, to your question, how do we scale up, or how do we scale this across multiple sites? If you can scale across vSphere, you can scale with this platform. If you need higher performance, how do we add nodes and make them scale easily and simply with the skills we have? vSphere and NVIDIA AI Enterprise provide that for you. Whether you are doing initial training testing in a small way, and then you want to grow that, and then once you have it, you want to set it out to inference in a large way. Whether you want to, let's go back to the retail example, or let's go back to a different example with the detection of people in masks, and you might put it into one street area that's a common plaza, for example, and then you want to scale it out across multiple locations. Again, the software stack of vSphere, Tanzu, and NVIDIA Enterprise helps you scale that out quite simply. You are literally just adding more nodes that receive more data and analyze it accordingly. It's really quite straightforward. So this is really important. And this is actually what the University of Pisa found as well. Simplicity is really, really important, right? If we have complexity, we have fragility, we have problems, and we don't want to build a business on fragile IT ecosystems. That's inherently a problem, right? So scaling this out was great for them as well. And they did it in Italian, which is always very stylish. Another example here, Mass Brigham. So this was a hospital in the United States, obviously based in Massachusetts, as it says. And they were providing AI-enabled applications through a variety of AI applications to clinicians and healthcare professionals in their business and others. So to provide that, again, they had front-end systems, some of which were mobile, some of which were based on computers. And they're all back-ended by, again, some bespoke AI systems. And what they found was, this comes back to that sometimes AI projects fail, is they had the real challenge of scaling from a proof of concept, which worked, to an enterprise system. And the interface between the AI people and the IT people, this is where the problem often occurs. The IT people say, we cannot adopt those systems because they are not standard. And the AI people say, but we need this tooling to make sure it works. And this is where we provide that tooling for you. So, Richard, to your question of the struggle with how to scale this across their business, this is exactly how we do it. We make sure that our platform, A, can achieve all of the requirements of the people who are using the tools. And that's both the AI practitioners and the IT people. And then after that, it's literally just adding nodes and scaling it out accordingly. And if you want to adopt, as some people do, you start off building one type of AI and then you want to build others, we can help with that too. One of the key things about NVIDIA AI Enterprise is it gives you access to something called NGC. NGC is called the NVIDIA GPU Cloud. Now, the irony is it's actually not a cloud, it's a cloud repository. Sort of like a GitHub location for you to pull things down. And what we have in there for customers like Mass General is the ability to download as many different types of frameworks as you want. If you want to do natural language processing, we've got about 6 or 7 of them. If you want to do computer vision, there's a couple there too, some of which are partially pre-trained, which accelerates your adoption. So that training that takes a long time, now it takes even lesser time. We've got specifically a lot of information and a lot of tool sets in healthcare. There's a system called Clara. Clara has got drug discovery. It's got genomics with something called Parabricks. It's got a Clara Guardian, which is a language interaction piece. So when surgeons, for example, are wearing their gloves and they can't touch a computer, they can talk to Clara, things like that. And there's a Clara medical imaging piece as well, which is common for scans, things like that. We've got a couple of customers here in Australia doing it to very great effect, very interesting stuff. So this NGC capability is designed to augment your data scientists. When we talk about data preparation, Rapids is ready to go. When we talk about some other tools, such as computer vision like, they're ready to go. Worth exploring. Free to use. There is paid support for it, but free to use. So no worries there at all. And of course, last but not least, we have some information for you if you'd like to dig more into this. There's some information both on VMware's site and on our site as well. And more importantly, if you have AI people who well, you need to run this past, because if they're not going to use it, it's not going to work. In fact, the same goes for your IT people. If they want to feel comfortable with it, we actually have a framework called Launchpad. And Launchpad actually is some pre-hosted machines ready to go and ready to test. And you can apply for that as well. Just do a Google search for NVIDIA Launchpad. And that's fully available today for people to use in our cloud. You get a 2-week access to it. And you can actually run real live AI frameworks. We have some pre-written labs for your data scientists or your IT people to walk through and get a taste of the experience. Whether you want to build a chatbot or do some computer vision or do some AI orchestration for the IT people, those labs are all there for you. So having said that, I'm going to flip to Q&A. We've already had one question there as well. So if anybody else has any additional questions, I encourage you, please pop them in the chat window, and I'll be more than happy to answer those for you.